All right, so we're going to do translation now, and then we're going to do some more examples. So, whiteboard. All right. So when we were doing matrices, we did a whole bunch of transformations. So we did reflections, we did rotations, we did a whole bunch. Translations are generally used with vectors. So if I have a Cartesian plane here, and let's say I have a triangle there, and I have the exact same triangle there. Now, let's say this coordinate here is, say, 5 and 1. And then that coordinate over there comes out at 10 and 6, for example. This shape is translated, and remember, translation, unlike in English, translation in maths essentially just means you're moving. You're taking a shape as it is, and you're simply moving it horizontally, or you're moving it vertically, or both, as in the case of this one. So here you are moving it horizontally, and then you're moving it vertically. Same shape, same orientation, just different place. So your vectors, we also learned about adding and subtracting vectors. And we learned that all you do is you add component by component. So if I want to write this translation as a vector, it is literally just putting my horizontal on the top and my vertical shifts at the bottom. So how much am I shifting horizontally? Well, I'm shifting 5 units horizontally. And if I'm starting here, I'm going from A to B, am I going to the right or am I going to the left? Well, I'm going to the right, which makes it a positive. Do I need to write the positive? No. If you want to, feel free. What about my vertical? I'm also going from 1 to 6, which means I'm moving 5 units. Is it a positive or is it a negative? Well, I'm moving upwards, which makes it positive as well. So therefore, my translation vector would be 5, 5. Because if I take any coordinate here, such as my 5, 1, and I add on my translation vector 5, 5, I could have 5 plus 5, which makes 10, 1 plus 5, which makes 6, and that is the coordinate that I end up with. Very often, this type of translation comes up in your core exams more than your extended exams. It occasionally comes up in extended literally as one sub-question, so it's not a huge part of your exams, but it is good to know because it also kind of just closes the book on your transformations. All right. So I'm not going to do too much on this. I just wanted to make sure that I got this out the way, and then you guys can move on from that. Any questions on this? Well, if there are, feel free to type it in the chat. All right. So let us move on to our examples, because that's the fun stuff. Yeah. Stop. I need to share this one. All right, let me try and position these nicely. All right, and then I can position this one next to it. All right, so I am going to share my screen, main screen. All right, there we go. So last time, if you remember correctly, we had this diagram. And what we were doing is that we found out PQ, QR. So there's my Q, there's my R, and that was that vector over there, which is the same as this one, OT, and therefore it is just Y. PQ, well, from P to Q, that's that vector there, which is the same as that one. But from P to Q, we don't really know what it is. But what we do know is that we could create an extra triangle over there with vectors that we do know. And the vectors that we do know was this vector over here and this vector over here. So it was a horizontal and then a diagonal upwards to the left in a northwest kind of direction. So therefore we could create that, and then it's x plus y. Then we were asked for the position vector of S. And the position vector means that we're starting at the origin, and we're given that O was the origin, to get to S, which is y plus st, and st was the same as pq, being x plus y. Or if you didn't realize that, you could just add another y and then another x, and you get 2y plus x. And that's great. And we got that. And luckily, there weren't too many hang-ups about that. Now, part B of this question says, the line SR, and that's this one here, is extended to G, so that SR to RG is in the ratio of 2 to 1. So we found that SR was X, meaning that RG must be a half of x. Well, that makes sense. RG is, SR is double the length of RG. That's x, that must be half of x. We need to find GQ. So that means from G to Q. Now, how are we going to do that? Well, luckily, it's actually not that difficult. But we've got to remember that with vectors, there is one golden rule. To find a vector that we don't know, use vectors we do know. So if we want to go from G to Q, we have to go from G to R and R to Q. Hopefully that makes sense, because we know this one, we know that one. So I'm going to redraw it here just so that it's a little bit bigger. That's G, that's R, and that's Q. Great. So we know that this was a half x going that way, because remember vectors, direction, crucially important. We know that this one was y going that direction, but we want this direction. So we are actually looking to go the opposite direction of both of them. We want that vector and then that vector to go from G to Q. So that purple vector is minus a half x, and that one is going to be minus y. And therefore, my answer here is minus a half x minus y. But is that in its simplest form? No, because it asked it for its simplest form. There is a common factor here that we can take out. That is in its simplest form. So I'm not sure if you're going to have to do that, but again, this is a simpler version. So try and remember to look for the fact that you can take out a negative. All right. Part C, M is the midpoint of OP. So M is the midpoint of OP, so that's there. So there is my midpoint, M. Great. Find MG. So that's that vector over there. Find MG in terms of X and Y in its simplest form. Great. Do we know this vector? Does it relate to anything? No. But we can travel along roads that we know to get down to there. So we're from G to M, we're going to have to go from G to R. Then we go R to S. Then S to T. Then T to O. And then O to M. So let's add all of these together. So G to R is going to be minus a half X. Because remember, it was in that direction, so minus direction, minus a half X. That direction is minus X. That direction here, ST, we found out what ST was. ST was the same as this one, which is X plus Y, but we're going in the opposite direction. So it's minus X plus Y. Then we're going to TO, that is Y, but in the other direction, minus Y. And then from here to there, that is a half of X. Please note, it's the only one that is a positive over here. Very important. The reason it is a positive is because from O to M, that is in the direction that X, the vector X, was given in. So we can actually simplify this because that cancels with that. And then we have a minus X, distribute the minus in, minus X, minus Y. And therefore this can be simplified to minus 2X minus 2Y. Once again, please note I'm drawing the lines underneath it because that is how we symbolize a vector using handwriting, because we cannot write in bold. So it's minus 2X minus 2Y. Everyone happy with that? Any questions? Anyone feel like I've done anything incorrectly? Anyone feel like I've led them down the garden path? Maybe we need to kind of read the question again. So could that be simplified? Rebecca, you are 100% correct. That could be simplified to X plus Y. Thank you for that. Very happy. Very happy. However, remember, I just worked out GM. The question asked me for MG. Very different question. And what is the change then going to be? The change is going to be the fact that it's not in a negative direction, it's in a positive direction. All right, so this is GM, but if we want MG, it is going to be the negative of GM, which is minus 2X minus 2Y, which makes 2X plus 2Y. Make sure you answer the question and don't fall into the trap that I just fell into. So the minus 0.5 confuses you. The minus 0.5, so is that the minus 0.5 you're looking at? That one. All right. So that is because of this line over there. That's a half x. Because you were told by the ratio that this is half the size of that whole thing. And to get from there to there, we had to go back along the half x. Remember, the half x was in this direction. But we're now going that direction, so it's negative, and then down, which is also negative. And that's why it's a half. So it's half x going along the top, full y going down the diagonal. All right. And then final question here, it says, H is the point on TQ. There's T and there's Q, TQ, so that's that horizontal black line. And you have some point H, so that TH to HQ is 3 to 1. So there's my point Q. So my point Q, my point H. So TH to HQ is 3 to 1. So that is 3 times as long as that length is. Use vectors to show that H lies on MG. So I was close. That point should actually be over there. All right, how are we going to do this? So we need to prove that H lies on this line. How? So we've been given this ratio is 3 to 1. So if we can find how long TQ is, well, maybe that can help us along the line, because that would then help us to use the ratio bit of information that was given. And how are we going to do that? Well, we can either go from T up, across, down, or down, across, up. Both of them will give you exactly the same answer. So I am going to use a light green. So we're going to go up, we're going to go across, we're going to go down just because that's my choice. So that up over there, so to find TQ, that's not 100% legible. So TQ is going to be that one, which is x plus y. Then our horizontal, which is x. And then that one, which was minus y. And I know that's minus y because that going in that direction is plus y. Therefore, this is minus y. All right. So this is a minus y and a plus y cancel. So that leaves me with 2x. So how does that prove, will help me prove anything? Well, I need to remember that this is split in the ratio 3 to 1. So if I have a look at this, I want to try and find h over there. Well, if that whole length is 2x, what is the length just up to h? Well, it's going to be 3/4 of the whole length. But Richard, why 3/4? How are you getting 3/4? I don't see any 4s. Well, hopefully you know about ratios. If it's split in the ratio of 3 to 1, in total there are 4 parts. And I'm looking for 3 of those, therefore it's 3/4. So therefore, the vector TH is going to be 1/2 of my x vectors, because that's 3/4 of 2. So I now have that vector. But how is this going to show that h lies on this vector MQ? So we found MQ, MG. So this vector mg here, we found that that was 2x plus 2y. But how? How can we find that it's on the line? So if we have a look at MH, we see that this line, so there we go, MH. MH is that one. How can we find that length? Well, do we know it? Well, we could maybe go back that way and then down and then across. Because again, if you don't know the length, use roads that you know the length of. So we're going to go from there across, which is minus 1.5x minus y plus a half x. So just one more time, I'm going to write in a bit of a darker color so that you guys can see it. So this is HM or MH. Doesn't matter which direction we go because we can change it. So HM, so that's minus 1.5x going that way. It's minus y going that way. And then it's plus a half x going that way. So minus 1.5 plus a half gives me minus x minus y. So that's that vector going down here. But maybe we can kind of split this whole line. Because remember, we're trying to find that h lies on this vector. If we can show that h has to lie on it by splitting the vectors using my h point, and that those two together would actually give me my vector, h has to lie on the line. So let's use it as an MH rather, because I know that MH plus HG would equal, hopefully, MG. So MH is x plus y. Okay, great. What about HG? Well, H to G, we're going to go back 1.5. So it's minus 1.5x. We're going to go up there, which was plus x plus y. So we're going plus y plus x. And then we're going to go plus x plus a half x. So once again, we're just gonna travel with you here. Minus 1.5x plus y plus x plus a half x. So minus 1.5x plus x plus a half x cancel, and we're left with x plus y. But hold on. If MH plus HG equals 2x plus 2y, because it's x plus y, and x plus y gives me 2x plus 2y, that is exactly the same as what mg equals. Therefore, they have to be the same vector, and therefore, h has to be some point on the vector, because that's the only way you can split the vector like that. And that is how you have proven that h lies on your line. Now note, this is the last question, the last sub-question of this question 9. Of course, it is going to be more complicated. So it's very important you remember this. But as I said, and I'm going to say it for the last time now, the number one rule with vectors, often you'll be asked for a vector that you don't know what it is, but you will be able to find that vector if you go along the roads that you know and then get back to it. So start somewhere, start at the beginning, go along roads that you know until you hit the end point of that vector. sum them up, simplify, and that is going to be what your vector is.